Good morning, everyone. So we'll start with a new chapter that is terpenes and terpenoids. Coming to the learning outcomes, at the end of this chapter, you will be able to define what is terpene and terpenoids and differentiate between terpene and terpenoids. And also you'll be able to classify different types of terpenes and terpenoids and explain the biosynthesis of terpenes and terpenoids. I think we discussed the biosynthesis in some chapter, I don't remember. And also, most importantly, we'll be able to outline the botanical name, family name, uses, side effects, mechanism of action of different types of terpenes and terpenoids. Okay, so today's class mainly we'll discuss. So this is the learning outcome for the whole chapter. But today's class will mainly discuss the definition and classification of different types of terpenes and terpenoids, after which I will give you a lot of questions to solve. So we'll have fun today. So regarding terpenes and terpenoids, terpenes are a class of more than 20,000 natural organic compounds, okay, which contain carbon atoms multiple of 5. Do you remember this? I discussed this in one of the chapter. Who remember? Where we discussed this, and I said I will ask the same question again. Is there anyone who remember?
Saponins, doctor?
Yes, there you remember we triterpenoid. We studied triterpenoid glycoside. Do you remember? Spheroidal
Yes, doctor.
glycoside and triterpenoidal glycoside. So now you see we'll study the basics of terpenes and terpenoids. So terpene means these are class of compound which contain the multiple of 5 carbon. That means they can contain either 5 or 10 or 15 or 20, 25, 30, 35, 40 like this. Multiple of 5. Okay, and if this class of compound terpene they contain oxygen, they are known as terpenoid. This is the only difference between terpene and terpenoid. All right. We will go to the classification later. So you see the first one, can you tell me, you see there are 3 structures given. Gingiberine, which is found in the oil of ginger, menthol, which is found in peppermint oil, geraniol, which is found in rose oil. So how many terpene and how many terpenoid you see here?
1 terpene and 2 terpenoids.
Which one is the terpene and which one are the terpenoids?
The gingiberine is the terpene and the menthol and geraniol are the terpenoids.
Yes. Why they are known as terpenoid?
Because they contain oxygen.
They contain oxygen. So see, the oxygen can be present in any form, either in the form of alcohol, functional group, ketone, aldehyde or phenolic or acidic also. Okay. So the main thing you have to see, if it contains oxygen, they are known as terpenoids. Now the name terpene is derived mainly from the Greek word that is terebinth, and terebinth is a type of pine tree from which the terpenes were first obtained. And another important point that you need to remember, terpenes are mainly the primary constituents of essential oils of many plants and flowers. Okay, they are the primary constituents of essential oils. So we will go to next slide. So the molecular formula of terpene, it's a multiple of, remember, C5H8N. Okay, so where the N represents the number of linked isoprene unit. What is the isoprene? Isoprene is the first unit of terpene, the building block of terpene that contain the 5 carbon atom. So look at the structure of isoprene here. It is nothing but 2-methyl-1,3-butadiene. So if I ask you, what is the chemical name of building block of terpene? What will be your answer?
Isoprene.
Yeah, what is the chemical name?
2-methyl-1,3-butadiene.
Yes, 2-methyl-1,3-butadiene is the chemical name. Okay, but the building block, which is the building block of terpene, which is otherwise known as isoprene. So one isoprene unit contains 5 carbon atom. So must remember the chemical formula, just like flavonoid must remember the chemical formula here. Okay, and this is called isoprene rule because terpenes are made up of isoprene. All right. Now here, in this slide you will see how the isoprenes are actually linked to each other. If you look at the isoprene unit, they have two sides. One is known as head, which is the branched end of the isoprene. Okay, this one, left hand side, it is written as head, and the unbranched end of the isoprene is known as tail. All right, so isoprene units are generally linked with each other in the form of head to tail fashion. Okay, so that means the head of, you see the second one, head of, let me one isoprene, okay, joins with the tail of another isoprene. Once again, okay, this is, you see, I put a box. This box represents the tail or head portion of the isoprene.
This is the head.
Head.
This is the head, right? The red color region.
Yeah.
That means the head, yeah, head of one isoprene will combine with the, okay, this is the tail. You see the tail of another isoprene. So they join with each other head to tail fashion, not head to head or not tail to tail. Okay, so you will, this is another characteristic of terpenes. When you see the structure of terpene, they are joined with a head to tail fashion. All right, so remember this. Now here, the isoprene units can be linked, as I mentioned, head to tail to form either linear terpenes or cyclic terpenes. The terpenes can be either cyclic, okay, that is acyclic, that is in the form of open chain, or they can be also cyclic. We will see many examples. Here I generally show a small animation. So I'll go to the slideshow and just respond me if you see the slideshow. Are you able to see the slideshow? All of you?
No, doctor.
This is the problem. If I go to
No,
slideshow,
doctor.
no one can. Nobody can see. Okay.
No,
So
I
here
can
the
see.
okay. So unfortunately, I will not be able to show you the small animation how like head to tail conjugation takes place. But you understood, right? All of you understood how they combine with each other. So here I generally show an animation of myrcene, which is an example of linear terpene. Myrcene is a component of plant including bay, ylang-ylang, and thyme. So it combines with each other to form a linear terpene. So I really excuse me, since in Microsoft Team I'm not able to show you the animation. This is one of the negative feature. Now I go to different example. Yeah.
Doctor,
Yeah.
I want to ask
Yeah.
the N, which number represent?
Once again, this N you mean? Yeah.
Yes,
In N.
in the second
Yeah.
structure.
Number of N is the number of isoprene. If it is N is equal to 1, then it is only isoprene. Okay. If the N is 2, that means there is the 2 isoprene. So
Yes.
2 isoprene, yeah, do you understand? 2 isoprene forms one monoterpene. That classification we will see in the next slide, coming slide. Okay, we'll have clear idea about N. Okay, when I go to the coming slide. So I have not yet discussed the classification. So you see here are two examples, limonene, which is a cyclic terpene. It's a terpene or terpenoid, limonene. Look at the structure.
Terpene.
How many
Terpene.
isoprene?
Terpene.
Yeah, how many isoprene unit it contains? How many isoprene
I
it
think
contains?
2 isoprene.
Yeah. How many carbon?
10 carbons, that's why 2.
10 carbon.
We have 2 isoprenes.
Yes, so you can see it is given with a different color. Okay, red color 5 carbon, blue color 5 carbon. This limonene is present in the skin of citrus fruit, and this is the component which is responsible for the characteristic strong smell of orange. So whenever you see the smell of orange, it is because of the presence of limonene. Okay, now look at the second structure. The second structure, it's a terpene or terpenoid.
It says terpenoid because of the
Terpenoid.
oxygen.
Yeah, it's already
Or
written,
OH.
unfortunately. Yeah, it comes in animation generally when I ask in the class, so you don't see it. Anyway, so you know why it is terpenoid, because of the presence of OH. oxygen. It's the structure of menthol, which is present in peppermint oil. Now we go to the next example. All right. So can you see this one? How many isoprene unit is present in the alpha saline? 3. You can
15
see it is
carbon.
given 15 carbon. Unfortunately, it is written. So you can answer it. I cannot ask this question.
No,
Anyway, you
I
got
noticed
the
that due to
concept.
the color. That's why
Yeah,
I
yeah,
noticed.
yeah, yeah, yeah. Generally ask. Okay, next one. Camphor. Camphor is an example. Contain how many isoprene and how many carbon?
2
2
isoprene,
isoprene,
1, 2,
10
3, 4,
carbon.
5.
Okay,
10.
so you can see. Is it a terpene or terpenoid?
Terpenoid.
There's oxygen.
Okay, in which form oxygen is present?
In which form?
Ketone.
Yes, ketone. It is present in the ketone form, right? So same like this, you see the another one, another big giant terpene. Can you see that they are joined in head to tail? So how many isoprene present? And
8.
how many? Yeah, unfortunately written
40.
again. So 8 isoprene, 40 carbon atom. It is the structure of beta carotene. Tetraterpene. The classification, as I mentioned, I have not yet discussed. I will discuss in the next slide. Okay, the beta carotene is a compound that causes carrot and apricot to be orange. So the orange color of carrot and apricot is because of this beta carotene. Now coming to the classification, look at this. Listen carefully. This slide is the important slide. Okay, so when you have 10 carbon atom, it is known as monoterpene. So 10 carbon atom means how many isoprene?
2.
2.
2, right?
2
Okay.
isoprene.
Yeah.
So when it is 15 carbon atom, it is known as
3 isoprene.
sesquiterpene. 3 isoprene. 20 carbon atom, how many isoprene?
4.
4. 25?
5.
5.
Yes. So
5.
30 carbon?
Divided
6.
by 5.
6. So 40 carbon, how many isoprene?
7.
40?
8.
8. 8
8,
isoprene.
8. Yes.
Yeah,
8.
yeah. Always divide by
We divided
5.
by 5.
Okay. Now here, yes, so you understand, always divide by 5, you know number of isoprene. Now here you see if it is 10 carbon, we call it as monoterpene. Here you need to remember something. Okay, monoterpene. So if it is 20, then diterpene. Okay, so people get confused. Always remember, mono means 2 isoprene. So diterpene means how many isoprene?
4 isoprene.
4 isoprene. Triterpene means how many isoprene?
6.
Yeah, triterpene means 6 isoprene. Tetra?
6
8.
isoprene.
Tetra.
8. Tetra.
Yeah, tetra. So remember, mono means 2. Yeah, di means, see, mono means 2. So di means 4. You have to double, okay? Tri means, all right? Tri
6.
means 6. Tetra means 4. So see, now when it is 15 carbon, we call it as sesquiterpene. And when it is 25 carbon, we call it as sestarpene. Sestarterpene. So see, these two names are very similar, isn't it? Sesquiterpene and sestarpene. And it is difficult to remember, isn't it? Are you getting me, all of you?
Sister.
How you remember them? Which one is 15 carbon?
The
Which one
second
is
one is
25 carbon?
easier. Sister.
Any logical way to remember? Can you guess? Anyone can give me an idea?
For what?
You see, the sestarpene, all right? Sestarpene is known for 15 carbon. When it is 15 carbon, it is known as sestarpene, okay? But 25 is known as sesquiterpene. But my question here, you see, both are bit confusing. How to remember which one is cis-terpene, which one is sesquiterpene? So 15 and 25. These are the odd numbers.
15,
Clue.
6 retardant.
Again. Have you noticed one thing? Both 15 and 25, both 15 and 25, okay, they start with the same 3 letters. What is the same 3 letters? Ses, right? SCS. So it's difficult to remember. See, both of them have the same 3 letters, ses. After ses, what starts?
Quiet.
Yes, sesquiterpene. The 15 it starts with Q, right? And 25 it starts with
T.
T, right? So which one comes first? T come first or 25, 15 come first? Or Q come first?
Q comes first.
Q come first, right? So same like that. 15 come first or 25 come first?
15 comes
15.
first.
You understand what I'm trying to tell?
Yeah, according to the letters, which comes first? 15 comes before 25.
Yes, you
And
see,
in the
it's
alphabet,
just
that is before Q.
yes,
Q
yes.
before T.
See, yes, both of them start with the same letter, ses, right? SCS. So after ses, it starts with Q, sesquiterpene. So 15 come first. That means Q come before T. There is no science behind it. Okay, just the way to remember. This one I'm telling you based on my experience of correcting student paper. I have seen most of the student they do mistake. They know the names but write it wrongly. So how to remember sesqui, Q come before T. So 15 comes before 25. So sesquiterpene is for 15 carbon, sesterpene is for 25 carbon. Now, if the sesquiterpenes contain oxygen, what will be the name?
Sesquiterpenoid.
Sesquiterpenoid, right? If the sesterpene contain oxygen, what will be the name?
Sister-terpenoid.
Yes, sesterpenoid. So is it clear the classification, all of you?
Yes.
Okay. Now listen, read something that is given at the bottom, then I will give you a lot of exercise, which is not there in your lecture slide that you have taken. Okay, so hemiterpene is another term that is given that consists of single isoprene unit. The isoprene itself is also known as hemiterpene. So isoprene is also known as hemiterpene, remember. Okay, so if the hemiterpene contain oxygen, it is known as hemiterpenoid. All right, you see the hemiterpenoid and hemiterpene. Isoprene is also known as hemiterpene. Contain oxygen is known as hemiterpenoid. So there are two examples of hemiterpenoid I have given. You see here the structure, both the structure, prenol and isovaleric acid. So see why they are known as hemiterpenoid, because they contain how many carbon? 5 carbon with 1 oxygen. So attached to the oxygen, the prenol contain the OH group, whereas isovaleric acid it contains the carboxylic group COOH. Okay. Isovaleric acid is found in essential oils, whereas the prenol is found in various citrus fruits like cranberry, grapes, raspberry, blackberry, and tomato. Now we go to exercise. Now let's have fun. Let me see who can identify which one is which one. Can you tell me how many monoterpenes are present in the structure? All of you. It's a challenge for all of you. Let's see who can solve them
Again,
first. How many monoterpenes are present in this slide?
There is
This is
no
the last
monoterpene.
slide for today. What is that?
There is no
In what
monoterpene.
No
Are you sure?
monoterpene.
Are you sure?
Stiboicide is mono.
Which ones? Stibiocyte? No. Mono means
Mentho-
how many carbon and
men-
how many isoprene?
10.
10
Oh.
carbons.
10.
Mentho-glycol.
2 isoprene.
Mm-hmm.
Yeah,
Right,
two
There's-
teacher?
isoprene, 10
Mentho-glycol.
carbon.
Orthocyanide.
There's
I
three
said
monoterpenes.
monoterpene.
Mono
limonene.
mentho-glycol. 10 carbons.
Only one, limonene.
Limonene and terpenoid. The terpenoid, I think.
Terpenoid? No, not terpenoid. Why not?
It's terpenoid.
It is terpenoid is the monoterpenoid. You see, my
Yeah,
question was.
yeah, I get it.
Yeah,
Oh, okay.
yeah.
Limonene
So,
only.
okay. So listen my question carefully. All right. So the correct answer is the monoterpene. Terpene means mafia oxygen. Terpenoid means with oxygen, right? Free oxygen. So limonene is the only monoterpene. So having 10 carbon and 2 isoprene unit. So how many monoterpenoid you have? Now tell me. In the whole
Only
structure.
one.
Terpenoid.
Mentho-glycol.
Mentoglycol?
Monoterpenoids,
No.
right?
Yeah.
You said
yeah.
oid, terpenoid ولا terpenoid?
Terpenoid. Monoterpenoid.
Terpenoid.
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 Yeah.
And
How
these
many monoterpenoids you
3.
have?
There is two.
What about
Which one?
mentho-glycol?
Okay, mentoglycol. Okay, can you
These
count the
are
numbering?
all
10.
Mentoglycol. Yes,
Methylglycol and
mentoglycol is
terpenoid.
10 carbons. So mono.
mono. What is the another example?
Terpenoid.
How about the others? Terpeniol. Is it
Mentoglycol,
correct or?
terpenoid.
Yes. So
These are
terpeniol and yeah, what is that again?
Mentoglycol.
Mentoglycol and terpeniol. So these two are the examples of monoterpenoid. Why monoterpenoid? When I say monoterpenoid, you have to see how many things? Two things.
Two things.
Terpenoid means first you see, look for oxygen. Okay. And second thing, mono
10
means
carbon.
how many carbon? 10
10
carbon.
carbon.
Okay, good. Now
10
let me give you another. How many diterpene you see?
Di.
Hmm.
Oh. Di.
Retinol.
Are you sure?
20 carbons.
4.
Yeah.
4 isoprene.
In 20 carbon. How many diterpene?
Retinol.
Is it diterpene?
Stevioside.
Is it diterpene?
Yes, 4 isoprene.
No, see
There is
again
no
you
any
Terpenoid. No
diterpene.
oxygen.
There is no diterpene.
There is no.
Yes, very good. See, if I ask diterpenoid, then it is retinol probably because my question is terpene, not terpenoid. You understand
Yes.
or not? So always first thing remember, is it terpene or terpenoid? So if it is terpenoid, then look for oxygen. If I say terpene, so moment you see oxygen present, cancel the structure.
Yes.
If I say terpene, immediately cancel the structure if you see oxygen is present. So it cannot be retinol. Can it be retinol?
Oxygen anywhere.
What is that?
Oxygen on any side or
Any side.
anywhere.
If the structure, yeah. If the structure contain oxygen, it is terpenoid. Okay.
There is two.
Okay.
Stevioside and retinol.
How many? Stevioside? Are you
And
sure?
retinol. Yes, they
No.
are diterpenoid.
Yeah, they are diterpenoids.
Yes.
One is retinol. Retinol is the diterpenoid, right?
Yes.
And stevioside. Is it diterpenoid? Are you sure?
Yes.
How about the others?
I
There are
think so.
20
20
carbons.
carbon and oxygen.
Okay. How about terpenoid?
This is sesquiterpene, terpenoid.
Sesqui. How many carbon? Are you sure?
15. 15.
Can you count? Who can count?
Yes, I count them. They are 15 carbons.
Yeah, 15, I think so. 15
Yes,
carbons.
yes, they are 15 carbon.
How many open carbon in the terpenoid?
There are 3 open carbons.
Okay, very good. 3 open one you can see inside the ring, one outside the ring in the bold, and one in the form of double bond, right?
Yes.
So this is sesquiterpene. How about
Terpenoid.
the sesquiterpenoid? Very good. So how about bisabolol?
Yes, it's also sesquiterpenoid.
It is sesquiterpenoid. Okay. How about squalene? Can you count?
This is triterpene.
Triterpene or
Yes,
triterpenoid?
terpene.
Why?
Because there is no oxygens in the structure.
30
so
carbons.
30 carbon. 30 carbon means how many isoprene?
6 isoprenes.
Yes, 6. Because each isoprene contains 5 carbons.
Okay, so divide by 5, right? 30 carbon divided by 5, so 6 isoprene. All right. So all of you clear about the nomenclature of terpene and terpenoid? I
Doctor,
hope there's no.
bisabolol.
Yeah. Bisabolol?
Bisabolol. Yes. What it is?
Okay,
15 carbons. So cis.
how many carbon you see? Can you count?
15 cis Q and then the letter Q. Cis Q
Yes.
oid, since there's oxygen.
Can you explain in Arabic?
15 ذرة كربون يعني اسمه سيس بعدين حرف الكيو واويد بالنهاية لأنه في أكسجين.
Okay. Can you help to count the 15 carbon?
How do you help count them?
Yeah. How many cyclic carbon? How many acyclic carbon?
الاروماتيك
أي
6
أي
الاروماتيك 6 وعندك اول شيء فوق كربون وعندي كل نقطة كربون لحالها.
Yeah, see after OH is attached to one carbon, right? So that is one carbon. And that is also having another open methyl group. How many methyl group you see in the bisabolol? Let's count it this way.
4.
How many methyl group? 4 methyl group, right? Yeah.
4 methyl group, yeah.
Yeah, 4 methyl group. Now, other than this 4 methyl group, how many cyclic carbon? 6.
6.
So 4 plus 6, 10. Now, other than this, how many carbons are left over in the structure?
5.
5. You can, below the OH, you can see 1, 2, 3, 4, 5. Okay, because there is no animation, I cannot use the pointer also, unfortunately. Anyway, I hope all of you, it is clear. The person who asked me question, it is clear now? I can go to the next slide.
Yes, clear.
Okay, good. Now see here, now next few slides, you will understand very easily since we did this exercise. This is the first time I did this exercise in this semester. Previously, I didn't do. So monoterpene consists of, you read now, consists of 2 isoprene, that means 10 carbon units, and have the molecular formula C10H16. What is the basic formula of isoprene? How many remember?
C5H8.
C6H. صح
No,
C5.
no C6.
صح. Right.
C5.
No.
No, C5H8.
Yes.
So monoterpene means C10H16. So can I ask you here, monoterpene means somebody asked, I think Sarah asked me a question here. The N means what? Now in case of monoterpene, how many N you will see?
2.
2N.
Yeah, so in case of monoterpene, 2. In case of diterpene, how many N?
4.
4.
4.
4 N. And sesquiterpene?
3.
Sesqui.
3.
3.
Okay,
3.
so now you understand the concept of 3, right? The concept of N. And must
Yes.
remember this molecular formula because you can get one of the question like which of the following formula represent the isoprene unit. All right, now I go back to the slide. So say the examples are geraniol, limonene, okay, terpeneol. So we have already discussed them. Limonene present, which is responsible for strong smell of orange, and terpeneol is found in the pine oil. So next one is sesquiterpene, means it contains 3 isoprene unit and 15 carbon units, and have the molecular formula C15H24. Example, one of the examples are humulene, farnesene, and farnesol. So if you look at the structure of farnesene, what is this structure responsible for? It is found in the waxy coating on apple skin. So if you see the wax coating or the wax shine in the apple skin, is because of the presence of this alpha farnesene. Similar to, if you go to diterpenes, okay, now I think you can self-understand. It's composed of, diterpenes are composed of 4 isoprene units, that means 20 carbon, and have the molecular formula C20 and H32. 32 means 8 into 4, 32. Diterpene also forms the basis of biological important compounds such as retinol, phytol. They are also known to be antimicrobial and anti-inflammatory. So there are a lot of antimicrobial and anti-inflammatory compounds are present, which are diterpenes in nature, right? So one of the example is retinol. Same like that. If you go to the next example, sesquiterpene, sesquimine, it contains 5 isoprene unit, that is 25 carbon. Example is geranyl farnesol. The structure is not given here. And triterpene consists of 6 isoprene units with the molecular 6 isoprene means how many carbon?
30.
30.
So I can include here 6 isoprene units means 30 carbon. Okay, with a molecular formula C30H48. The linear terpene, that is squalene, is a major constituent of the shark liver oil. You need to remember this, which constituent is present where, what is the function. So I can ask question, which of the following triterpene is present in shark liver oil? So squalene. So squalene has natural and vital part in the plays a vital part in the synthesis of all plant and animal sterols, okay, including cholesterol, steroid hormone, and vitamin D in the human body. That's why consuming shark liver oil is very good for health.
Doctor,
Okay.
I have a question.
Yeah.
In our tradition, we use the whale liver oil, not the shark liver oil.
Okay.
Is it
Well,
the same thing?
I think yes, that also contains squalene. Well, liver oil. Hopefully, I'm 100% not sure, to be honest. Okay, I need to refer back and tell you. Okay, so let us find out and discuss in the next class. Well, liver oil. I'm sure it might contain the squalene, although I cannot tell you without referring back. Okay.
Because we don't use the shark liver oil at all. It's not common here.
Oh, but in our country it is common. We have a lot of supplements with shark liver oil capsules. It comes as a soft gel. You know the softlets? Yes,
Yes,
softlets
doctor.
within the
Yeah,
capsule.
even the whale liver oil comes like this.
Yeah, it will come in the yellow color softlets,
Yes,
shark liver
doctor.
oil.
It's the gelatin capsule.
Yeah, soft gelatin capsule. We call it a softlets, right? So soft gel. So we go to the next tetraterpene. Tetraterpene contains 8 isoprene unit, that is 40 carbon, and have the molecular formula C40H64. Biologically important, it is biologically important tetraterpenes include acyclic lycopene and the monocyclic gamma carotene and bicyclic alpha and beta carotene. So lycopene, so as you see the structure, okay, the lycopene, it has 11 conjugated double bonds, which gives the deep red color. Okay, and it is also responsible for antioxidant activity. So lycopene is responsible for the red color in tomatoes and watermelon. So if you see the presence of lycopene, it has two roles. Remember, lycopene has two roles. First, it provides a red color, and it is also responsible for antioxidant activity. So what does it mean? It means when you go to buy tomatoes and watermelon, don't buy the green color tomatoes, buy the red color tomatoes. It's not just because of the color. Red color also indicates it is rich in antioxidant property, that is lycopene. Same goes to watermelon. That's why these days in the market, many people will do the adulteration. They will put red color dye inside the watermelon to make it very nice red colors. But originally the red color watermelon means it contains a lot of antioxidant property, that is lycopene. All right. Next one is polyterpene. After tetraterpene, we call them as polyterpene if they contain or consist of long chains of many isoprene units. Okay, the nature, for example, the natural rubbers are examples of polyterpene, which consist of polyterpene in which the double bonds are mainly cis, okay, to each other. So with this, we will finish our lecture today here. So before I finish, can I ask a small question?
Doctor, I have a question regarding tomato.
Yeah.
Sometimes when we get a yellow colored tomato and leave it for a week, it turns to red. Why, doctor?
Or maybe there is a biosynthesis. The precursor of lycopene is present there, okay, inside the tomato. So when you keep it for longer time, it may get converted into lycopene. That is the reason you will see, even if you buy green, after some time you will see the green color fades, it becomes light reddish and something, but it will never become very nice red. Have you observed that? The one you get the very nice red color, original red color from the market, if you buy a green or yellowish, it will never convert into that red.
Yes, doctor.
Yeah. Because the lycopene does not come from outside the tomato, it is already inside. That means the precursor for the formation of lycopene, the isoprene units are present inside. It takes time. So it takes time to join and conjugate and convert into lycopene. So when you keep it, store it for longer period, the conjugations takes place. Some of them get converted into lycopene, but the conversion happens better when it is attached to the plant itself rather than being outside. Okay. All right.
This
So
process, doctor, belongs to, we can say, needs
the
light?
biosynthesis, yeah, inside the biosynthesis process, okay, the biosynthesis of lycopene takes place inside. Definitely it's inside.
Yes, doctor.
Now regarding lycopene, how many points you need to remember? The color and antioxidant activity, red color and antioxidant activity of tomato and watermelon. Squalene, okay, shark liver oil, and we'll find out next class whether it is present in the well. I am sure it is also present there.
I
And
searched about the whale,
yeah,
and only the shark turned out. I'm not sure, but this is what happened when I searched if the whale's liver contains squalene. It gave me information and websites about the shark.
I see.
Indeed,
Okay.
information. Squalene, it says it's omega-2. That's new information. Anyway,
Okay.
whale
Yeah.
liver didn't appear.
Okay, we will search it and discuss in the next class. Any other questions you have? So before we finish.
No.
Okay, so we will finish